So, hello everyone, and welcome to this Ask AuxEn Anything uh, online session that we conduct every weekend. So, as you all know, it's an online platform where civil structural engineers can interact with us and where they can uh, discuss their doubts or queries related to steel or RCC concepts or any project that they're doing or site and construction issues. So this is the 37th such episode that we are conducting. And so let us begin by taking on your queries. So I'll I'll take the queries that have been put in the Google form, and then we will take queries from the live comments. So let me just begin. So I'm just sharing my screen. Just hold on. Yeah. So the first query is for this week has been asked by engineer Vineet Kabadi. He is from Pune, and what he is saying, all peripheral RC special moment resisting frame. So he is quoting this clause from IS 13920, which is the requirement for your dual system, if I remember correctly. All peripheral RC moment resisting frame need to resist this. Okay. Let me also have a look at the clause exact provision that is there. So I'll just open the. Is it from 1893 or 1392? I think the R table has this statement. So it is from 1893, that table which gives you the R values. This particular line is provided over there. So let me just try to bring that table here and we'll see what's written in that table. I think it is table number 9. Yeah. Where is it? Dual systems. Where is the 25% clause? Okay, yeah. So flat slab in and structural wall system. It is in the flat slab and structural wall system. This provision I think is given. Perimeter RC. So perimeter RC special moment resisting frames. Is it from the same line? I'm just struggling to find the provision. There is this dual system, and I think even in your dual system, this provision is there. C note 1. Can anyone just help me out? I'm just struggling to locate this provision. Anyway, I'll just take this to be the clause right now. Flat slab with structural wall system perimeter RC frames need to resist at least 25% of design lateral force. Uh, there is one more line somewhere which says even in the structural wall systems, that peripheral RC frames need to take that. I'm not able to recall. So anyway, I'll just explain what how this can be done in the software. So let's say you have a structure over here which is having perimeter RC columns, peripheral frame, let's say. Okay. And then you have some walls inside. So it's a dual system. You have some walls inside. It's a very, very childish diagram, but imagine this to be the diagram right now. So you have got, let's say for the EQX direction, what will happen? You have got these shear walls that will resist your EQX. Now, in addition to this, what will also happen that your peripheral frames, because they are on the periphery, these will also attract large axial forces and they will resist the earthquake force in terms of the axial forces. So all of us know how earthquake force or how lateral forces are resisted. So lateral forces are resisted in two ways. So if there was an EQ force acting like this, one way to resist earthquake forces is through development of end moments. Now, what will happen that in case of, let's say this is my shear wall will resist M3, but this will be of a very high magnitude because the shear wall has a very large stiffness. So this M3 will be numerically significantly high as compared to M1, M2. So one way to resist earthquake forces is this, but there is also this other way by the creation of axial tension compression couples. So through creation of axial tension compression couples, these EQ forces are resisted. So let's say this column will generate, and don't worry about the direction of arrows right now. I'm just making arrows so that the direction is reactive in nature. So don't worry about the arrows, okay? Don't worry about the sign of arrows. So these columns will have axial tension, these columns will have axial compression, and this will be of a significantly large value. And let us say their distance is uh, L, this height is H. So all of you know how the earthquake force, and let's say this total force was F. So how this total earthquake forces are resisted? So number one, this F will be equal to, and then there will be some shears also. So let's say this shear developed is V1, V3, V2. So your lateral force will be equal to V1 plus V3 plus V2. Now numerically this V3 will be of a significantly larger value as compared to V1, V2. And the overturning moment that will be created, F into H, this will be equal to M1 plus M2 plus M3 plus this T into L, or you may write it as C into L also. So this will also be a significant component. This axial tension compression couple will be a significant component. This M3 will be a significant component. And in shear terms, this V3 will be a significant component. Now, what the code is saying that perimeter RC moment resisting frames need to independently resist 25% of the design lateral force. Okay. So when it says that it needs to resist 25% of design lateral force, both the effects of earthquake, that is the shear and the overturning moment, have to be uh, resisted by this frame. Understood? So what you can do now, this is all jugaad work. There is no clear cut provision given in the code for this, that how to incorporate these things in the software. It's not very clearly given. So now when your EQ is in X direction, what will happen? These columns, because they are the farthest from the, because they are farthest from the uh, this point about which effects of EQX will be felt, these columns will have the maximum tension compression couples. Okay. So first what you can do is that you run your analysis model and then check what forces are getting transferred in the columns and what forces are getting transferred in the walls. Then you try to find out approximately what percentage is being resisted by the columns, what percentage is resisted by the walls. So roughly, as I told you, when it comes to resisting the base shears or shears, columns will resist a very small amount of shear. Maximum shear will be resisted by walls. So this equation may not be very useful, but then you focus on this equation. In this equation, what's happening? This m1 m2 were the, let's say, the moments resisted by columns. These will not be significantly higher, but this m3, that is the moment resisted by the wall, and the tension compression couple resisted by the columns, these will have significant values. So you can just try to find out the percentages. So just to give you an example, suppose my total overturning moment was 100 kilonewton meter. Now out of this, 80 kilonewton meter is getting resisted by wall, and the balance 20. So how will you find out this 80? From your analysis results, you will get that how much wall is resisting, and then the balance, you can say, is getting resisted by the columns in the form of axial tension compression couple. Okay. Now what did you want? As per the codal provision, you wanted that it should resist 25%. So now this is all jugad work. Now what you can do, that for, let's say, EQ, when the force applied was EQ, you saw that columns are resisting 20 kilonewton meter of the moment. But what do you want? You want 25 kilonewton meter to be resisted. Why 25? Because 25 percentage is what you want. So you wanted 25 kilonewton meter to be resisted. So what extra amount of movement needs to flow to column? Again, very rough calculation, 25 upon 20. Okay. So this will give you what? 1.25. So now you need to magnify, or you can magnify the earthquake forces by this magnitude. So instead of applying an EQ force, you apply 1.25 times EQ. How you can manage that? Either you multiply this factor straight away in the load combination or load case, or what you can do is you can magnify, let's say you could magnify the importance factor so that automatically the EQ force goes up. One of the two strategies you can use, and then you can apply this force in your model, and then check your columns for this. Am I clear what I am just explaining? So for columns, you make a special load combination where the EQ is replaced by this, so that around 25% of the earthquake forces are, uh, I mean, the effects of earthquake forces. Sorry, I'll just repeat. You do this 1.25, so that what is happening, you are allowed to or you are able to ensure that around 25% of the effects of design lateral forces are getting resisted by columns. So this is a jugad work that you can do in such cases. Again, it's not clearly given in the code. They have just written one line, but to incorporate that, this is my opinion of doing this work. Now there can be obviously different other options possible, but to my mind, this is one of the easier options that you can do. In our course on flat slab systems, we have done these things in detail for an actual building. Okay. Okay, let's move ahead. And the next query asked is, so this was engineer Vineet with his query. The next query is, just hold on. What has happened? The system has just stuck up. So let me just see what's happening. Are you able to see the screen now? Whiteboard? Yeah. So let me just take up the next query. Next query has been asked by uh, engineer Vineet Kumar from Patna, and he's saying, I have sent you an email regarding a project I have designed Kindly review the sizes and overall scheme and discuss the procedure for its erection. Oh, so I mean, reviewing the size in online session will not be possible, but let's have a look at what he has sent. So he has shared this image. So this is a radial truss that he has prepared. Similar question was asked in the last session. Just hold on. Yeah. So this is his scheme, and this is his radial. Uh, this is the compression ring, and then these are the columns on the circumference. I think at some locations these columns seem to be out of place, and then these are the trusses. Orange lines are the truss, radial truss. Okay. So, and then this is the compression ring that he has provided, this blue thing. So this compression ring, this is the compression ring, and then these are the columns, and then this is that radial truss. So this is the system. Compression ring member, it's not quite clear from the section BB. Okay, I think this is the compression ring, and it will be circular. So reviewing sizes, I mean, I cannot do it in a live session just by looking at the drawing. But these connections you need to present in more detail, how the exact connection between this radial truss and the compression ring is happening. That you need to present in your drawing in detail. Discuss the procedure for its erection. So erection, although I have not seen erection of such a system practically, but what I can think from first principles is that initially these columns, these will be placed, is my understanding. Okay. This ring they will install and support it by props. So this ring will be installed and supported by props. Okay, these columns will be placed, and then you have to start placing these trusses. Remember that this compression ring will be only stable when all the trusses from all the sides are connected. Okay, so you cannot have truss only joining from one side and no truss from the other side, because that will lead to instability in your compression ring. So I think first you have to place this compression ring and prop it up, maybe create a platform or something so that it does not move here and there, and then you start installing your trusses. And below your trusses also, initially you could place some props, although be careful with the props, because those props will add to the bending moment and it may change to behavior of the truss. So be careful with how you are putting the props on the truss. And then you could, I think you could place these trusses diagonally. So first you place this, then you place this, then maybe you place this, you place this. So diametrically opposite trusses you can start placing. All the time this central ring is supported, and then once all these systems are then in place, then maybe you can remove the prop from below. This is my thought process, although I have not done this type of a, or I have not seen this in person, this type of an installation procedure. But these are my first thought uh, on I mean, these are my first thought when you ask this question. Okay, right. Then what else do we have? uh, then Mr. Sovan Ghosh from West Bengal, he is a working professional. He's asking, is there any course on bridges, box culverts, etc.? No, we don't have any courses on Bridges. Bridges we have, but those bridges are steel pedestrian bridges. So I don't think you are asking about steel pedestrian bridges. You are asking about the RCC bridges. So for RCC bridges, we don't have any courses. Neither we have courses for box culverts, etc. Then the next question is from engineer Abhijit Sathe. He is from Pune and he is a working professional. He has two questions. Uh, while designing floating column, gravity column, what criteria for design to consider? So floating column is different, gravity column is different. You should not be putting them with a slash. These are two separate items. Okay. So floating column and gravity column is not an interchangeable term. These are two very different things. So gravity column you may look for in section I think 11 or 12 of IS 13920. They have given the design process. Although the process is not very clearly explained, but the process is given in 13920. Mainly you have in gravity columns you have to ensure that your column behaves well under the effect of drift or under the effect of lateral sways. So although your gravity column is not taking any moments from the seismic loads or lateral loads, still they have to maintain the compatibility. So your code wants that the gravity columns should behave under the effect of moments that get generated from the lateral sways. So it's like a P delta effect for gravity columns that you have to consider mainly. In gravity columns, the biggest challenge is that your columns in the structure should not take moments and they should not even take any effect of lateral loads. So the challenge of gravity column is not the design of gravity column as such, but to ensure that gravity columns do not take any effect of earthquake loads. Now that cannot be moment, that cannot be any axial tension compression couple also. So to that and I mean ensuring that is a bigger thing than designing the gravity column itself. Designing gravity columns, you have to just consider this additional moment that your columns may be subjected to r times delta times the axial load. Okay, so design your columns for this additional moment, but in the model to ensure that columns are not taking any effects of lateral loads are is a bigger challenge. Uh, for floating columns, I mean, there's no different criteria. You just need to provide your column and uh, put it on your beam or whatever. And some people try to provide releases at the column ends, but that is not correct way. So don't put any releases etc. at the floating column bottom, and then just proceed as you do for a normal column system. Okay. The second part of his question is how to design against heavy uplift pressure for basement draft. So basement drafts, what do you mean by heavy? What is the definition of heavy? So let's say it's a three basement. You have got three basements. Okay. So imagine that your ground level, this is your ground level, and you're talking about, let's say, 12 meters below ground, and you had a substantially high water table, sorry, and your water table was, let's say, 2 meters from ground. So you are talking about 10 meters of water table and 10 meters of water table pressure, 10 meters of buoyancy force to be taken by this raft. So almost what 100 kilonewton per meter square of pressure to be taken by raft. Now this is substantially heavy, so to say. Now in these cases, what you need to be careful about, that there are two things. See, if you are talking about a building which has three basements, let's say it will have 6 7 stories above also. So when your building is constructed and all your dead loads are in place, then in the raft, I mean, you will get some substantial pressures, isn't it? Maybe you will get, I mean, even if you were to check the bearing pressure below the raft, let's say if it is reaching, I'm just taking very rough examples. Let's say it is reaching around 180 kilonewton per meter square pressure. This is the bearing pressure below the raft due to all the dead loads coming from the superstructure. Okay, and let's say dead load plus live load maybe. Someone may argue that full live load is not possible, so dead load plus some percentage of live load maybe. So this is the bearing pressure. Compared to that, take this uplift. It's quite low as compared to the bearing pressure that will be exerted below the raft. So in such a case, what happens, that uplift is not a problem per se. Uplift is not a problem because this building is having such a large sulfate that your uplift pressure is not going to cause any problems in the raft. This is point number one. So here you may not have to be you may not have to worry about this situation. The real problem occurs when you had three basements. Okay, and basement construction will happen step by step. You are already 12 meters or whatever, 12 meters below. Water table is from 2 meters. You have got your water table. So buoyancy forces are acting to a large magnitude of, let's say, 100 kilonewton per meter square are the buoyancy forces. 10 meters of water table. The real problem is not after building construction, but the real problem occurs when, let's say, you have only made one basement. So raft has been provided, the other levels are ongoing, construction is ongoing. Now this is a problem. Why? Because at this stage, when you do not have, or when you don't have constructed all the floors, now here the bearing pressure below the soil is significantly lesser than the eventual value. You're getting this point? See, after construction, water table was not a problem because the dead load bearing pressure itself was significantly higher than the uplift pressure due to water table. So that was not a problem. The problem is that during construction, let's say you started your construction in April, and by the time May or June, you had cast one raft, and then monsoon season came, it started to rain, water table has risen up. So now this is the worry, that you only have one raft and the bearing pressure is very significantly it's significantly lower, so to say, and now you compare it with the uplift pressure that you are getting. Now this is a problem. So in such cases, what you can do, you don't have, here the mechanics, this weight itself is significantly lower than the uplift pressure. So here, whatever you do design wise, it will not help. This is a stability issue right now. You understand? So in such cases, what can be done? Number one, you try and release this pressure. How to release this pressure? So you may leave vertical gaps or holes. We have done these kinds of work in our projects where we have just left holes in the raft. Understand? We have left holes in the raft so that what happens, even if rain occurs, the water will just come in and it will fill up your raft. No problem. Raft will get flooded. Absolutely no problem. Let the raft be flooded. Let the construction work stop for 1 2 months. Anyway, in rainy seasons, the construction process is slow, so let it get flooded, and you may continue with your construction work above, and first basement gets flooded, whatever. This is one way, and then of course you can pump the water out. You keep on doing the pumping. This is one way of doing it. The other way is what people do, that let's say they had constructed one basement, they will just fill it up with soil. They'll just fill it up with soil and check the stability so that raft does not get uplifted. So these are the things you could do while the construction is ongoing, and you want to just hold on. Yeah, so this is the approach you could do. So uplift, uh, this is the stability check. And then other than that, you could, well, now let's say your building is constructed. At the final process, if you at the final step, if you want to check for uplift, you just see what is the uplift, what is the bearing pressure due to your service loads, and then you provide the reinforcement accordingly. So first step of uplift design is to check the stability. Your stability should not be compromised. The second step of checking for uplift is to then provide reinforcements if they are required and at whatever locations they are required. Okay. All right. So this was his query. Then we have another query. Mr. Akash is asking one side. Mr. Akash Babar from where is from Mumbai, and he's a working professional. Let's see what he's asking. One heavily loaded steel process tank is resting on RCC ring wall of 4 meter height, and ring wall is supported by octagonal pile caps having 19 piles arranged in a circular fashion. What does this mean? Octagonal. One heavily loaded steel process tank is resting on RCC ring wall of 4 meter height, and ring wall is supported by octagonal pile caps having 19 piles arranged in circular fashion. I am not sure what he's saying. Equipment operating, equipment empty, equipment hydroset weight, seismic shear, seismic moments, wind shear at one point only. Should all these loads be applied at a single point in safe model on pile cap, or should I model a ring wall with rigid links and apply point loads on top? Geotechnical team has provided horizontal string constant at every 1 meter interval of pile length. Oh, is it? Maximum, minimum of or average value. Is there any recommendation on thickness of pile cap? Shall it be 3 times the pile dia to ensure rigid action behavior? No, I think you need to provide sketch for this. You need to provide a sketch for better understanding of this query. Your equipment supplier has given all the load inputs at one point only. Which is that point? Is it the center point? Which point is it? Just see. See, if it's a ring wall, let's say, I've not understood this octagonal pile cap, what you're saying, but I'm saying this is the plan view. And let's say typically the equipment supplier has given you the values at this point only. Now, what you do is you just make a pile. Okay, so this is a ring wall you are saying, right? So, now you want it to transfer it to all the points. So in safe, I don't know if rigid links are possible. I have not seen this option of rigid links in safe. I would have done this manually, manual calculations I would have done. But if you want to do it in safe, rigid link option is not possible, I guess. Is it possible? Is Mr. Akash is confirming it is possible? Good. So if it is possible, then I have not tried this, but I would have done this manually by, let's say there are 19 piles. Is this how you have placed the 19 piles? Circular? Is this how you have placed the 19 piles? So if this is the, if this is how you have placed the 19 piles, maybe I would have done it manually by just finding out the section modulus of, I would have found out the reactions in each pile, and I would have assumed that the reactions in each pile will be proportionate to their distance from the axis of bending, and like we do in normal cases, that those will be proportional to their distances from the this centroidal axis, and that's how I would have found out. So I would have done force in this pile F1 is proportional to x1, force in pile F2 is proportional to x2. So I would have said force in the pile is kx1, force in second pile is kx2, and now the moment about this will be how much? So the moment resistance will be F1 into x1 plus F2 into x2, Fn into xn. So these are only on one side of the centroidal axis, and maybe multiplying it by 2, I would equate this to the total moment given in the system, and I would have replaced F1 by kx1, F2 by kx2, and so on. So the only unknown now is k for me, because these x1, x2, x3 distances are known. From here, I would have found out the x. From there, I would have found out the reaction in each pile, and that's how I personally would have done it. But if you're saying that you want to do it in safe and you want to use the rigid link option, Mr. Akash is informing that rigid beams with large I22 and I33 values may be provided. Maybe you could create a very, very thick slab over here on top of it, a very thick slab, maybe with no self weight, and then you could apply a point moment to this, and then see how the loads are getting transferred. Maybe something like that. Although I'll have to experiment it myself before I'm able to give any reply to this query. Okay. So these things I would have done it manually, like this process that I just explained. But in safe, maybe just create a very, very thick circular shell and don't have any self weight assigned, and just see if the load distribution is happening in the way you want it. Or the rigid link option can also be explored, although I have not tried this option myself. Okay. The next part of his query is geotechnical team has provided horizontal spring constants at every 1 meter interval of pile length. What value of horizontal spring constant shall be used? At every 1 meter they have provided. I don't know. So you mean to say if my pile is 6 meter, they have given you 6 different constants? And if my pile is 5 meters, have they provided 5 different constants? Is that what you're saying? I'm not sure if they give report like this. Maybe for 1 meter pile, they have given you a pile constant at 1 meter. For 2 meter, no, Mr. Akash is confirming that they have given. So for if the pile is 6 meters, they have given 6 different spring constants at 1 meter interval. This is new thing to me also. So then maybe, although this thing should be confirmed with the geotech person, but then maybe they want you to provide 6 different spring constant values. I don't know. Is there any recommendation on thickness of pile cap? Shall it be 3 times the pile dia to ensure rigid action behavior? See, in this rigid action behavior uh, may not be required, because your centroid of the tank and centroid of the pile will coincide. So as long as the loads are gravity loads, uh, your all the piles will have same reactions in them. So in this case, rigid action as such is not required. So the pile cap thickness you can find out with respect to your normal flexure and shear checks. Uh, this rigid action thing may not be very much required for this case. Okay. Yes, Mr. Akash is informing that for 23-meter pile, 23 horizontal spring values have been given, each varying over the length. This is good. You should share this report to me. Maybe remove the client name and just give it. I will also have a look. Interesting. So this was his query, Mr. Akash. Then let us move ahead. Mr. Dinesh from Tamil Nadu is asking, and he is a working professional. So he is saying, what he is saying, some consultants for designing steel portals, some consultants for designing steel portal frames, the support of frame, assuming as fixed, releasing MX or MY, when to adopt this fixed but case and how to achieve this at site. Okay, and there is a related query on the same question by engineer Salman Droj. He's saying size of footing or shed can be reduced if we consider pinned joint instead of fixed. So these both of them are similar queries that how to decide the joints at the bottom of the portal frame. So generally, some where you see people provide pin supports, and in some portals they you see people providing fixed supports. So now how to decide where to provide fixed, where to decide where to provide pin. So basically, when you provide pin, what happens is that to footings only your moment sorry only your translation forces flow. Of course, due to translation you may have to add on this effect additional, let's call it D. So there will be an additional moment created at the base due to this translational reaction, but then overall moment, there is no end moment that is flowing to the foundation. So pin supported systems may be adopted, especially at locations where you have poor soil conditions, where you know that footing sizes. I mean, if there is a moment in the footing, you may require large footing sizes, and that is what you want to avoid. So if that is your design requirement, people try to go for pin supports. But the problem of pin support is that they may be subjected to large lateral sways. So if you are providing pin support, then you have to ensure that your sway is controlled. You may have to add bracings, or you may have to come up with elevation bracings or plan bracings, or come up with some other scheme. So if you are providing pin supports, be careful about the problem of lateral sway, and you need to come up with ways to control it. If you provide fixed supports, what happens for footings? Then there is an end moment, and there is a horizontal reaction. So at base you get large movements, due to which your footing sizes may be footing size requirement be large. So in cases or at locations where lateral sway is a problem, or let's say you have got good subsoil conditions, you have got good strata, and you're not very worried about the footing sizes over there, you may come up with these fixed support systems. So this is how mostly the designers or the fabricators decide whether to provide fixed support or pin support. Now in steel sections, if I talk about the I section thing, generally if this is the plan view, to provide pin supports, and let's say moment is about this axis, to provide pin support they will provide bolts very close to neutral axis, just holding down bolts, and this is an approximation through which they can assume a pin like behavior. I'm using the term pin like. It's not an exact pin behavior, but pin like behavior. For I section columns, if you want to come up with a fixed support or a moment rigid joint, then you have to place, let's say, these gussets, and then you may have to provide bolts. So generally in PEB systems, the designers provide their bolt arrangements like this. Both flanges are connected. This is one of the systems that most of the PV suppliers adopt. Okay, so both the bolts are provided on either sides of flanges, and then they provide additional stiffeners like this. So this can be a rigid like system, rigid like behavior. Okay, so this is how approximately these things are done. So I think that answers the combined queries. Then Then this query is being asked by engineer Tamilarasan. He is from Tamil Nadu, and he is saying, what he is saying? For A-type trusses, example PEB portal frames for deflection check, which length has to be used? Total span of A frame or half the span of A frame? What is a A-type truss? Portal frames. No, obviously you have to check the for deflection check. Obviously it has to be column to column span. So if this is my portal, you have to take this span L for deflection check. IS 800 gives deflection limit for individual load case. For live, it will be span upon 360 or span upon 300. And for dead plus half live, deflection value should be given as pre-camber. My question is, for live, the deflection value should be given or dead plus live? No, dead plus live you give. There is an amendment to this provision. There is an amendment to the statements that were given in IS 800 2007, this table 6 for deflection. There is an amendment whether this deflection value, whether these permissible deflections are for dead or dead plus live. Earlier, I think the code had written only dead, but later on it has been amended that it has to be dead plus live. So you just go through that amendment once. Okay. All right. So my opinion is that giving pre-cambers on site is generally not very difficult in steel fabrication. So you ensure the permissible deflection limits are met for dead plus live. Okay. Then Mr. Tamilarasan, no, Mr. Dinesh from Tamil Nadu is asking, we have designed a RC cantilever slab for slab of 14 feet by considering short-term, long-term creep and concrete stress. The design was executed at site. After removal of shuttering, when we jump at free end, we can feel vibrations. No, there will always be vibrations. See, any cantilever slab, or for that matter, any normal slab will have vibrations, and especially at the ends of cantilever slab, you are bound to get vibrations. You cannot have a completely damped system. Even if you uh, stand on a bridge, okay, bridges are not cantilever; they are normal bridges. You stand on a bridge, even a small car goes on that bridge, you feel the vibrations. So vibration control with the sort of thicknesses that we provide is not possible. So you will always have vibrations. What you can do is that these vibrations can be damped. Once you do the flooring, you will see that those vibrations will come down and you will have lesser effect of those. For vibration analysis, there is no clear cut guideline given in the Indian code as far as I remember. There are some guidelines given in IS 16700, but those are also not very clear cut guidelines. But then you could refer to some provisions that are given in, I think, these books by uh, Taranath Bangali. I think in his book he has given some checks for the frequency calculation, and those frequency calculations are given with respect to the deflection. And then he has given some provisions that frequencies should be maintained above or below this value, whatever. So perhaps you could refer to those guidelines. But in a cantilever slab, there will always be vibrations that you will feel. So you do these additional checks for the slab in future, maybe. Yeah. Mr. Sandeep Badarshahi from uh, Porbandar, he is asking analysis. He is a working professional, independent consultant. He is saying or asking analysis of multiple tower on a single model in ETABS or any other alternate software. No, no. Why do you need an alternate software? You do it on ETABS. Do it on ETABS. Why do you need a multiple software? Why do you need a alternate software for that? Okay. Then we have next query from engineer Santosh A from Bengaluru. He's saying, asking how to design foundations for pipe supports, just as you do it for other structures. I don't understand why there is this whole complexity created around pipe structures or pipe racks. If you understand the basics, it's just like any other structure. For pipe supports, if you're typically asking, assuming the pipe, you have to keep it directly on the foundation. So if it's not a pipe rack, you're asking for direct pipe support, generally in case of pipe support, you provide what is called as a thrust block. Okay. So I am saying here pipes directly resting on ground. Okay, I'm not saying about pipe racks where you have made a steel frame and that steel frame is resting on ground. No, I'm talking about pipes directly resting on ground. So here you have to provide what is called as a thrust block. So and typically these thrust blocks are important where the pipe changes its direction in plan. So if your pipe was like this and then the pipe took a turn, and at the turning point you have to provide a thrust block usually. So then you have to find out the hydrodynamic forces in the pipe, and from there then you have to do these calculations for this thrust block. I have done these calculations in the company where I had worked before, but then they had some pre-designed Excel sheets, so I don't remember the formulation much. Uh, but somehow they managed the thrust block in a way by providing weight. So weight was the criteria of providing this thrust block, and then those weight calculations were done on the basis of the hydrostatic and hydrodynamic forces flowing in the water. So something like that they used to do. So I did this when I was in the where I worked before. Yeah, but okay. Distribution, Mr. May. Next question is by Mehdi Ali Khan from Kolkata. He's a working professional. He's saying distribution of reinforcement on column face depends on which factors. So I'm not sure whether he's talking about longitudinal reinforcement or transverse reinforcement. I'm assuming he's talking about the longitudinal reinforcement distribution. So this depends on number one, what sort of moment capacity or what sort of section you have, what sort of moments your section is going to resist. So let's say if your section was to resist moments only about one axis primarily, maybe I could focus more on providing reinforcement on this face. If my section was to resist moment about this axis, or if my section was to resist moments only about this axis, maybe I could only provide, or maybe I would have provided reinforcement only about this axis. But generally my columns have to take biaxial moment, so we distribute the reinforcement on all four faces. Now these spacings have to be decided by the SP34 guidelines, and how you are going to finally provide the links or ties to this column. That is an important criteria in deciding how the reinforcement arrangement you will provide. So my suggestion to you would be just go through SP34 guidelines of providing links, and those additional criterias are given. And from there also, this spacing thing or the distribution of longitudinal reinforcement you will understand. Okay, so read these criterias and you will understand. If you don't understand the SP34 things, we could discuss it again in the next session. So these were the comments on the Google form. Now let me just have a quick look at the comments queries that have been put in the live chat. Mr. Vasu Badania is asking, while assigning seismic loads, is it necessary to provide both static and dynamic load cases? Yes. Scaling the dynamic results through a static base shear is already done. No, so if you have already see first you define static load, equivalent static load case, you check what is the base shear, then if required, you do the dynamic analysis. Once you do the dynamic analysis, then you do the base shear scaling. Once you do the base shear scaling, then you include the response spectrum cases or the dynamic cases in your combinations, and then that's it. Okay, all right. Then Mr. Rishabh Thakre is asking, in ETAB's output of shear wall flexure design, does web be designed for moment and boundary element for bound? Huh? Okay, so I think he had shared one image. Just hold on. Mr. Rishabh had shared one image, so I'm just bringing that image for our reference. Where is that image? Just hold on, I'm just trying to find that image. So he had shared this image. Am I able to rotate it? Rotate left. Right. And then he has shared one more image today. What is that image? Oh, okay. He has shared this image. So now what he is saying, in ETAB's output of shear wall flexural design, is the web designed for moment and boundary element for boundary element design? What does this mean? Boundary element design of flexure moment can also be taken by boundary element. See, I'll just explain what you need to do. You take up these moments. Okay. Uh, where is it? You have these moments. So here, let's say this is my shear wall. It is whatever, say 1500 mm, and this was 200 mm, whatever. So the axial force is 1412. Moment is major moment about the axis is 290. Minor moment is 38. So what you do is, first of all, and then okay, now let's say you are going to provide boundary elements. See, this ETABS design of shear walls is slightly problematic because ETABS does not consider the boundary elements and other things properly. So what you do is do like this. Now this is the web portion. Okay, this is the boundary element portion. Now this web, let's say you decide to provide a boundary element of 400 mm, let's say, or 300 mm. Okay, I have not even checked the stresses. I am straight away decided to provide boundary elements because they are a good element to be had in our walls. So now how much web we are left with? 900 mm, let's say. Now imagine that ETABS gave me the design output as whatever. How much percentage it gave you? Is the percentage given somewhere? No, it's not showing me the percentage, I think. Anyway, so let's say that it is showing 1.43% was the ETABS percentage in the wall. So I will say that I will continue to provide 1.43 percentage in my web. Okay. Now what is my web size? Web size is 900 by 200. So you can find out the moment capacity of my web alone. So you find that out, moment capacity of web. How will you find out? You can use the annexure A of IS 13920 to find out the moment capacity of this web. Accordingly, do that. Then you say that my total moment was 290. My capacity of web is whatever you have found out. So my boundary element will take the moment to be taken by boundary element is the total moment minus the moment capacity of web. Okay. Now what you do, this moment capacity of boundary element will be resisted by the tension compression couple which will be generated in the boundary element. So T into this distance, center to center distance, this to this. So T into X or C into X will be the moment resisted by the boundary element. From here you find out the T or C. From this T or C, you find out the reinforcement to be provided in the boundary element. No, not so fast. Yeah. So this is the T or C due to moments. Now you also find out the axial forces, how much boundary element will take, how much the web portion will take. This you can distribute proportionately to the plan area. So you find out proportionate distribution, how much web will take. So out of the total PU, how much of axial load web will take, how much of boundary element will take. So once you have that proportionate distribution, you have the axial load to be taken by boundary element. Half of it will be taken by each boundary element. So you add it to your TNC, this half of the boundary element axial load to be taken. From here, you find out the reinforcement in boundary element. So if you are going to provide the boundary element, you should take the advantage of providing that boundary element and do a calculation like this. Do not rely on the ETABS results for shear wall design, especially with boundary elements, because ETABS is not able to consider the boundary element capacities, and if it considers, it uses a simplified CNT approach where it does not consider any moment capacity of the web. So follow this procedure if you want to provide boundary elements and if you want to do manual checks for it. Okay, done. So this was his question. Then Mr. Magaj is asking, is it good to model slab for domes in ETABS? Yes. Why do you think it is not good? You can do. Then Mr. Salman is asking, we have already taken this query. Mr. Salman is asking, G plus 1 small residential bungalow. Can we design columns as gravity? No, see, if there are seismic loads that are expected, you have to check for seismic loads. It's not if as if G plus 1, G plus 2 matters. If it can have seismic loads, you have to take into account the seismic loads also. Mr. Ajinkya Dinapurkar is asking, we provide pedestals if the foundation fails in punching shear. When we provide pedestals as per clause this, it becomes impossible to comply with this clause. What is this clause 34.1.3? What is this clause 34.1.3? I'm not sure. Let me check. Concrete clause 34.1.3. 34. If someone has screenshot, just share it to me. Oh, this is that clause 34.1. No, this is not 34.1.3. In case of plain concrete pedestals, well, why are you providing plain concrete pedestals? In case of plain concrete, we do not provide plain concrete pedestals. We provide pedestals with reinforcement. So how come this provision is not valid if you are providing reinforced concrete pedestals? Okay. Yes. Uh, okay. Then Mr. Salman Roj is asking how to design lugs for RCC beam resting over steel column. I think you want to ask the opposite. RCC steel column resting on RCC beam. So although I've not checked for lugs myself, generally design of RC, this is my RCC beam, and let's say there was a steel column, and you want to provide, let's say this is the plate, and then these are the lugs. So see, my understanding on this issue is that these lugs will behave like a holding down bolt. This will be similar to a holding down bolt. So first you find out whatever are the reactions that will be transferred to this lug. Let's say in the plan view, this was my base plate, and I had provided the lugs. Okay, generally lugs are provided like this. So in plan, I am more concerned about these legs of the lug. Okay. So my sense is that first, and this is my column. So first you find out how much of a reaction will be transferred to each point. This you could do in your normal process as per the axial load and moment in the columns. You figure out how much of a reaction will be transferred to all these points. On the basis of these points, find out that what is the axial capacity of this, and accordingly you need to also provide the bond length. If it's compression, you only take the straight length. If it is tension in this lug, you can take the complete length, bent also. So necessary bond length should be provided. This lug, whatever bar size you are using, should have the necessary axial or tension stress capacity. And then for this insert plate, so this is called as the insert plate. So for this insert plate, you design your insert plate in the same manner you would have designed if you had these 4 bolts, let's say. So if you want to reduce the thickness, it is better to add stiffeners and all those things to your column. So that process remains the same. For lugs, my sense would be design it as you do for bolts. So the reaction calculation and those shall be done as you do for your normal bolts. Mana Media is saying good information. Good, thank you. Mr. Soham Trivedi is saying while providing an expansion joint between two RCC buildings apart from the drift limit, what other criteria should be taken into consideration? Are there any guidelines? Guidelines I'm not sure about, but if your drift criteria is met, then you need to focus on how or with which material you are going to effectively fill this gap. That is what I think. Okay. Mr. Salman Roj is asking how to design punching shear reinforcement in safe software. I have not used the punching shear reinforcement given by the safe software directly. Usually I like to do manual calculations for the punching shear reinforcement. So in our course on uh, flat slabs, we have dealt with this punching shear reinforcement calculation in detail. But otherwise, I don't like to refer to the output given by safe because I have not verified it till now myself. So I don't. I mean, I don't usually use it. Okay. All right. So these were the queries and questions and comments that had been put for this week. So we have taken up all the queries that were asked on the Google form, and we have also answered to the queries that were put in the live comments. I guess I have not missed anything. So that's it then for this week. Thank you very much. We will see you with another episode uh, when we meet you next weekend. Till then, have a good time and see you next weekend now. Thank you so much.